So it's going to record all of our audio, and it's going to record whatever is showing on my screen.
Okay.
Okay. And then if you go to the top of your GoToMeeting panel, you'll see two little arrows there that represent the ability to minimize that so it doesn't take up so much of your desktop. You see where I'm talking about? Not the X, but next to the X, where it says shrink controls.
Yeah.
Okay. Cool.
I got it, and now it's in the middle of my screen, up above.
Yeah, it's not quite as big that way. Alright, let's start out the same way we've always started out. And the only difference is here is I want you to give me your answer as quickly as possible.
Okay.
I'm not going to turn the timer on, but I want to start paying more attention to time, and that's a little easier to do when we're doing it online. It's a hard one. This is 2 digits into 2 digits. Plus or minus?
It's going to be a negative.
Okay, -8 is what it is.
Yeah.
Okay, this one? Always give me the plus or minus first.
It's going to be a -3. No, -5.
What's 5 times 5?
Oh, sorry, -6.
That's okay. I want you to, in your head, that's the process you should always go through. In other words, when you came up with 5, always be checking. Always check to see that 5 times 5 is 30. Well, it's not. So it must not be 5. It must be 6. What the heck? Hold on a second. I'm getting all division problems here. Why am I getting?
But that's going to be -4.
Okay.
What we just had.
Why am I getting all division? I've got each one of them checked. Huh. Interesting. All right. What's this one?
-5.
There we go.
-15.
Okay, this problem is actually -10 plus 5. In other words, those two negatives turn into a positive, right?
Yeah.
So what's -10 plus 5?
-5.
This one?
-30. 90. 11. 1.
Good.
Is that -4 plus -2? It's kind of fuzzy.
Yes.
Okay. -6.
Okay. Here, let's see if I can do something about that. Hold on a moment. Let me see if I can blow
9.
Let me see. There. That should be a little better.
Yeah.
Yeah. Okay.
9.
Good. Oops, hold on. I got to be in the box. Okay. Just make sure you know how to do long division good. Here.
Is it 12?
It is. But let me go through it with you, just because it took you a while to come up with it. Now, I know one of them was negative, but I don't care. The main point is to figure out what the number is, and then figure out the sign. So if I'm doing long division, I'm dividing 8 into 9, which goes 1 time. Multiply 1 times 8. Subtract subtract gives you 1, bring down the 6, divide 8 into 16. That's how you get 12.
Mm-hmm.
And in this case it was negative 12. So what's 10 times 12?
120.
Well, we have one more 12 onto that. So add 12 to 120.
132.
Okay, positive or negative?
Negative.
Okay, good. Now, you notice how I did that. I didn't do 10 times 11 to come up with 110, because then I would have had to add 2 more 11s to that. So it's much easier, if I'm thinking about it, to do 10 times 12 and then add 1 more 12, because it's 11 times 12 instead.
Negative 20.
Good.
5.
Good.
15.
Positive or negative?
Negative 15. Sorry.
Going to count by 4s or count by 6s?
6.
Count up 4 of them.
6, 12, 18, 24.
24
So it's going to be
is
negative 24.
Not only is 24 what 4 times 6 is, but it's also what 8 times 3 is. Odd for them to give us the same problem immediately, almost.
Negative 14. Negative 44.
What I like is you're no longer questioning the sign. You know the sign.
Negative 1.
Almost every single time you know the sign.
3. Negative 3. Negative 132.
Good.
Negative 10.
One more.
Negative 8. No, positive 8.
Good. All right. Go on. Okay, I think today I'm going to depart from that one book that I've been using and go to my algebra book. And let's just review some problems. This is nothing harder than what we've done already. Hold on a minute. Alright. This is an equation because it has an equal sign. And we're to solve for x, which is the only variable. What's the first step? In fact, what I'd like you to do is read me the next line that I'm going to write. What are you going to do on the left side?
We're going to have to take away the parentheses, which means we're going to have to multiply the 4 by everything in there.
Okay, go ahead.
So it's going to be 4 times 3x.
Okay, tell me what that number is. In other words, tell me the next line. I'm not going to write it as 4 times 3. I'm I'm going to multiply.
12x minus 20 equals -2.
Hold on. You got to do the same thing over here. In other words, you
Oh,
get
yeah.
rid of those parentheses, right?
Mm-hmm. So it's going to be -2x.
It's negative times negative.
Positive, so 2x. Plus.
It's negative
Plus.
times positive.
Negative. So it's going to be minus 12. No, sorry, 16.
And this is still minus 6x. Okay, so goal number 1, I've gotten rid of the parentheses. I don't have any denominators anymore. Now what's my next step?
To solve it.
Now, yeah.
We have to get all our variables to one side and all our numbers to the other.
Very good. So how many total x's go on the left? Am I going to bring my x's to the left or to the right?
I like it on the right. Wait, no, left. So you're going to need to bring...
Normally, most people like it on the left, okay?
Yeah.
But there's no difference from it being on the left or the right.
No, I said left.
What I usually use is whichever one's going to give me a positive coefficient.
Oh.
Like negative...
So then it would be on the right. Because...
No, you're correct. We got a 12x here. We got a plus 2x there. And we got a minus 6x there. If we bring everything to the left, we're going to have a positive coefficient. Okay. Now, there's a couple of ways you can do this. Let's go through it step by step. In other words, let's combine the x's first on the right side. Let's do this step just to make sure. What's 2x minus 6x?
2x minus 6x would be negative 5x.
Yeah.
No, sorry, negative 4.
X. So now I've simplified it. Now, notice that if I bring this 4x to the left side and change its sign, I'm going to have a positive coefficient on the x's. Whereas if I were to take the 12x and move it to the right, I'm going to end up with negative 16x. Well, I don't want a negative coefficient if I can avoid it. So I'm going to bring this over to here, which means I'm going to bring this over to there. What's the next line going to read?
It's going to read 12, no, sorry, 8x
All right, let's talk about
minus 36.
Let's talk about this for a moment. You're making a very, very common mistake that I see a lot. Now, what they're going to teach you in algebra class is they're going to teach you to do this like this. Right? In other words, you always do the opposite of what it is. If it's a negative, I got to make it positive. I got to make it disappear from the right side. Okay? That's going to give me 16x on the left.
Oh, yeah.
Okay? Now, until you get really good at it, this is the way to do it. But once you've done it for a while, you don't need to really waste the time adding 4x, because I can do that all day long, but I know what I'm going to get. I'm going to get 0 after I do it. Right? So why even write it? My method that I like better is if I want to take something and move it to the other side of the equation, I just do it and change its sign. So to move this minus 4x to the left, just make it plus 4x. And then I end up with 16x on the left. Well, now I have this minus 20 that I want to move to the right. So what do I end up with on the right?
4.
Good. In other words, I'm going to change its sign, make it plus 20, and then I have minus 16 plus 20, which is a positive 4. What's the final step?
Dividing 16 by 4.
The other way around, dividing 4 by 16. And again, the way they're going to teach you this, or probably already have taught it to you, is to do this. And that leaves x equal 4/16. Simplify that. What's 4/16 equal to?
4.
16/4 would be 4.
Oh.
Let's talk about this. I have a numerator that is smaller than my denominator. If that's the case, the number cannot be greater than 1. The only way you get numbers greater than 1 is if your numerator is bigger than your denominator. If it's like this, then the number has to be between 0 and 1. So you were close, but it's 1/4. Now, how did I technically get 1/4? Well, if I take 4/16, I'm allowed to divide the top and the bottom by the same number, like that. Now, the top becomes 1, and the bottom, 16 divided by 4, is 4. So that's how I get the 1/4. Is that you can always divide the numerator and the denominator by the same number if you can do it. Let's do some more simplifications. Simplify that.
It's going to be...
What am I going to divide the top and the bottom?
1/5.
Good.
One fourth. One third. Oh.
Tell me what number you can divide top and bottom by. And you generally want to pick the biggest number. If you don't pick the biggest number, then you're not going to end up with a totally reduced fraction. So what's the biggest number that goes into 9 that also goes into 21?
One.
Does the biggest number? Does 2?
No.
Does 3?
No.
Look at 3 again.
Oh.
Follow everything.
So it's going to be 7.
Did you see everything I did, Logan?
Yeah.
Get 3 7s? In other words,
Yeah.
3 does go into 9 and 3 goes into 21. Now, do I know it's the biggest one that goes in? Well, even if I'm not sure, I'm just going to do that step, and lo and behold, I get a prime number on top and a prime number on bottom, so that's simplified. There's no further simplification required, which means that yes, 3 was the biggest number that would go into the top and the bottom. And this is one of the reasons that A+ math is so important, because there's no calculator in the world that's going to tell you what the biggest number that goes into top and bottom is. You cannot answer this with a calculator. You have to know your single-digit multiplication and division tables. All right, let's try another one here.
So first we're going to have to get all variables onto the same side.
Well, that's not a bad way to go. In other words, I'm inclined to agree, but there happens to be a step that'll make this much simpler. What can I multiply both sides of the equation by? Remember, in algebra you can always do whatever you want to one side as long as you do it to another. So is there a number that I can multiply the left side by and the right side by that gets rid of all denominators? The denominators is what makes this problem complicated looking. So if I can get rid of all denominators in one step, let's do it. What can I multiply the left side and the right side by to get rid of all denominators? And you generally want the lowest number.
So 1.
No, I won't get rid of the denominator. In other words, if I multiply that by 1, I'm still going to have 1/3 x. If I multiply it by 3, that would get rid of this 1/3, but then it would leave me with 3/4. So I would still have a fraction. So let's keep going. Let's see, what's the least common denominator between all of these denominators? If I was adding 1/3 plus 1/4 plus 1/6, what would the least common denominator be?
3.
Okay, first of all, your least common denominator has to be divisible by all your denominators.
7 and 6.
4 is not divisible, or 6 is not divisible by 4. So here's the way you get it. You take the biggest denominator and you start counting up by 6's until you find a number that is divisible by all 3 numbers. Well, what's the next number you get? 12. Is 12 divisible by 3?
No.
Yeah, it is. 12.
Oh.
3 goes into 12 4 times. When I say divisible, I mean, does it give you a whole number answer? Is 4. Does 4 go into 12?
Yeah.
And does 6 go into 12? Well, we know 6 goes into 12 because we counted up by 6's. So that means that 12 is the least common denominator. Well, that's what I'm looking for to solve this problem. In other words, if I multiply both sides by 12, I'm going to get rid of all denominators. Watch what happens in one fell swoop. What is 12 times 1/3 x?
So it's going to be 4.
4x.
Yeah.
And what is 12 times 1/4?
2.
3.
Oh. Oops.
And now what is 12 times x on the right side?
12x.
And what is 12 times a minus 1/6?
-2.
Now, this is what our equation has turned into. This is like 10 times easier than what we started with. Agreed?
Mm-hmm.
Yeah, because it doesn't have any denominators. In other words, denominators are what makes problems hard. So if you can get rid of denominators immediately, always do it. And we've done it. Now let's solve this. Now tell me whether I should take my x's to the right and my numbers to the left, or vice versa.
Numbers to the left and
Correct.
yeah.
What's the next line?
It's going to be
At once. It's fine to do
5.
both at once, but it's fine also to do them individually.
5 equals 8x.
Perfect. Notice that I have nothing but positive numbers. And now x equals 5 divided by 8. Is that simplified?
Yeah.
Yes, it is. Okay. Now, let's just suppose that I brought my variables to the left side and my numbers to the right. Well, now I'm going to end up with minus 8x on the left and minus 5 on the right, which there's nothing wrong with this. Now I got to divide both sides by negative 8. So I end up with minus 5 over negative 8, which is the same as 5 over 8. So I get the same answer. It's just that I had to deal with all these. I got that negative sign, and both of those negative signs. Well, negative signs are a recipe for making mistakes. So if you have a choice, I usually go with whatever gives me a positive coefficient in front of the x. Now sometimes it doesn't matter which way you go, you're going to get a negative coefficient somewhere. So just choose the way that gives you the positive coefficient in front of the x. In other words, the very first thing I see when I'm looking at this is if I move this 4x to the other side, I'm going to have 8x. That's the way I'm going, regardless of what number results on the left side. Because sometimes you're going to have a negative sign on one side of the equation, and there's no avoiding it. But if you make the coefficient positive, you'll be better off. All right, let me look in my book here and see if I can find some more problems. Let's just try. I'm going to randomly, well, not randomly, I'm going to pick the hardest ones because the others are too easy. These aren't hard, but they can always give you problems just because there's a lot of negative signs and there's parentheses. And all right, next line.
It's going to be a
Don't do anything more than one step. In other words, the next line you're going to get rid of the parentheses only. Don't try to do multiple steps at once.
So, wait, is that negative on the very first? Negative? Is it like quoting the
x plus 2 end parentheses?
Oh.
So you have to distribute this negative sign to both terms.
It's going to be negative x plus negative 2.
Well, that comes out like that. In other words, you don't want to ever write something like this. Okay? I mean, you could, but then you still have parentheses. In other words, you still have to decide what to do with that combination of a plus and a minus. Well, whenever you're adding or subtracting and you have a plus and a minus next to one another, it turns into a minus. Okay? So that negative sign applies to the x, and it also applies to the plus. So you get that. And then we have another minus 2x there. And then how about on the right side?
It's going to be a negative 2. Wait, sorry, no. Negative 2x.
Okay.
Negative 2x minus 2.
Perfect. Now what's the next thing to do?
then you get all the variables onto one side and all the numbers onto the other.
Yeah, the problem is that there's three variables. There's one there, there's one there, and there's one there. So if you try to do all of that at one time, it makes it harder. So let me throw in an intermediate step, which is to gather together like variables on one side first, before you combine all the variables. So what are the total amount of x's that I have on that side right there?
3.
Negative 3.
Negative 3.
Right? Because you have a negative x minus 2x, which becomes negative x plus a minus 2x. So that's negative 3x. Still have the minus 2. So I just put in an intermediate step just to combine that with that. Okay? Now you're at a point where you can move everything over.
So we're going to want to move the variables to the right side.
Good. So what do you end up with on the right side when you move all the x's over there?
You end up with 1x.
Perfect. And what happens when you move the numbers to the left side?
0.
Correct. And notice that when you're solving equations and you get to this point right here, and you have a minus 2 and a minus 2, you can immediately just do that. So now you have minus 3x equals minus 2x, and the only solution for that is x equals 0. Okay. See if I can find another one that... Yeah, there aren't. The problem, it's not a problem, it's a good thing. But the thing about these is once you figure out how to do them, then there's nothing that's tough. It's the same process every single time. You get rid of denominators, you get rid of parentheses, you combine your variables on one side and so forth and so on. So what's the next line here?
It's going to be negative 12 minus negative 4x.
Minus 4x, not minus a negative 4x. If I were to put minus a negative 4x, it would turn into plus 4x. Okay, so the only thing I want to distribute is that times that. Well, when I have negative 4 times x, I got negative 4x.
And then it's going to be plus 5 equals 4x plus 12.
Okay. What's the next thing to do?
Like you said, well...
Let's combine our numbers on the left.
Yeah. So it's going to be 7,
Plus
negative
5.
7.
Okay.
And minus 4x.
Next line.
You're going to want to move the numbers to the left and the variables to the right.
Good. So what are my total numbers on the left?
Wait, numbers? I thought...
No, you said it right. You said numbers to the left, variables to the right. The reason is because if I move this to the right, it's going to
be 5.
It's going to have a positive coefficient in front of the x.
It will be 5.
No, it'll be negative.
Negative.
Because I have to subtract 12 from both sides. What's minus 7 minus 12?
Negative 5.
Negative 19. You see why?
Yeah. In
other words, if I turn it into an addition problem, it becomes that. -7 plus a -12, that's -19. Okay?
And it's going to be equal x.
8x. In other words, I have to add 4x to both sides to get rid of that. Okay? And that's the reason that you wanted to move the variables to the right side, was so we would have a positive coefficient. Now, notice that I still have a negative number, but there's no avoiding that. In other words, if I go back up here and I choose the other method, which is to move the variables to the left and the numbers to the right, well then I get -8x equals 19. In other words, no matter which way I do it, I have a negative number involved. So sometimes you just can't avoid having a negative number. And in this case, it really doesn't matter. Since I'm going to deal with a negative number anyway, I could have 8x equal -19, or I can have -8x equal 19. Obviously, I'm going to get the same answer, which is what?
Sorry, I had a drink in my mouth. It is going to be,
Positive or negative?
It's going to be a negative.
Give it to me in unsimplified form, and then we'll see if we can simplify.
I'm kind of confused right now.
Okay, 19/8. In other words, what I'm doing is I'm dividing both sides by -8. Remember, what I'm trying to do is I'm always trying to get the one side with the variable down to just x. So whatever's operating on it, I got to get rid of that -8. Okay? When I divide both sides by -8, I get 19 divided by -8, which is -19/8. Now, let's talk about that for a moment. That is the same as this, which is the same as this. All three of those are identical. So it doesn't matter where your negative sign is. Now, if I had this, well, that's different. That becomes 1/2, positive 1/2. But all I'm trying to say is that it doesn't matter whether your negative sign is in the numerator, the denominator, or out in front of the ratio. They all mean the same thing. Okay. Let's do more equation solving. That's actually the essence of algebra, is solving equations. That's really what it's all about. And most equations have multiple ways that you can solve them. Okay, there's not just one way, and there's not even one obvious way. In other words, if I gave this problem to 3 different math professors, I'd probably get 2 different solutions. What's the first thing you would do?
I would try to get rid of the fractions.
That's normally the first thing I do. In other words, if I want to multiply both sides of the equation by 2, I'll get rid of all my denominators in one step. So let's do it that way, and then I'm going to show you sometimes where maybe there's a slightly easier method. Okay, so I can multiply the left side by 2 as long as I multiply the right side by 2. Now, what's the left side become?
It's going to be 2/3. No.
Hold on, what is this?
That is going to be 2 times.
The 2's cancel.
So it's going to be 1/7 x.
Not 1/7, but 7x.
7/1.
7 over 1. In other words, the reason I decided to multiply both sides by 2 was so that I would get rid of that 2. So that becomes 7x. What's 2 times minus 1?
Negative 2.
Over here?
4x plus 10.
Okay. So that turned it into a pretty easy problem, right?
Uh-huh.
But there's actually one thing you can do that's slightly easier than starting out by multiplying everything by 2. What if I move this minus 1 to the right side immediately? And now I have 7/2 x equals 2x plus 6, correct?
Uh-huh.
Now if I multiply both sides by 2, it's a little easier. In other words, I don't have to worry. The first time when I multiply both sides by 2 there, well, I had to deal with this 2 times this minus 1. So it's just a little easier if you get rid of any numbers that are being added or subtracted all off on their own by themselves, like this minus 1. Now we have 7x equals 4x plus 12. Move the 4x over, we got 3x equals 12, x equals 4. Okay?
Okay.
So that's what I say. There's 2 different ways to do the original problem, and I'm not sure one is superior to the other. My preference is to always, if I can easily move this 1 over, probably going to make the problem simpler, because it's actually one less step. Notice that if I move this 1 over first, then I don't have to multiply it by 2. So I saved myself one multiplication by doing it that way. What's one thing I can do immediately that makes this whole problem a little bit easier?
Getting rid of the parentheses.
Well,
or getting rid of the fraction at the very
not
beginning.
getting rid of the 4 on the bottom. How can I get rid of that 4 on the denominator? I mean, I agree that I'm always trying to get rid of all my denominators. But in this case, I have a 4 over here and a 4 over there. Gosh, if I multiply both sides by 4, I can do this. Bingo, immediately. So whenever you can do something immediately, do it. Okay, so now we have this is what's left. With me?
Yeah.
Now get rid of the parentheses.
So first you're going to want to do is get rid of you're going to want to go and get rid of the denominator of the 4/5 by...
Multiply 3 times 4/5 x. What do you get? In other words, before I can get rid of this denominator here, I got to do this distribution.
Yeah.
If I multiply everything by 5 now, it's going to get really complicated. But let's first of all multiply 3 times 4/5 x. In other words, let's get rid of the parentheses first. Sometimes you get rid of denominators first, sometimes you get rid of parentheses. It just kind of depends on the problem. And you'll get to a point where you know which. But make sure you know what 3 times 4/5 x is. Makes it easier, put a 1 under that.
So it's going to be 12/5.
Exactly. X. Minus what?
2. No. 5.
It's 3 times minus 2.
-5.
Negative 6. 3 times 2 is 6. 3 plus 2 is 5.
Yeah.
Don't get your multiplication and addition confused. That's why I have us spend so much time on A++. I think you're beginning to realize why that's so important. Is to be totally accurate on your single digit, and it's only your single digit that you really have to worry about. You don't have to be too worried about double digits. They don't come up that often. So now in other words, I've gotten rid of my parentheses. Now what's the next easiest step? Hold on a moment. There we go.
You're going to want to get the 6 to the
Good.
side.
That's the next best step. That's a better next step than multiplying everything by 5. It just is.
So it's going to be 17.
Now what's the next step?
And you have to get rid of the 5.
Okay.
By dividing,
No.
multiplying the 5.
Multiplying both sides of the equation by 5.
Yes.
Okay. So what's that leave me over here?
It's going to be
remember, the whole reason you do it is so you can do that. So what's left over there is always just whatever's left.
It's going to be 90.
17 times 5 is 85.
Yeah.
But my point is that you don't have to spend a lot of time thinking about what that is. The reason we multiplied by 5 was so that I would get rid of this denominator. That's the only reason. Okay. And now the final step is what?
Dividing 12 by 85.
You usually say that
85
back.
divided by 12.
That's the important thing. It may seem like a small thing to make sure that you say it correctly, but it isn't. It's a big thing. You want to always be thinking that you're taking 85 and dividing by 12, not 12 divided by 85, which is a different number. Now, can I simplify that?
I don't think so.
Well, I certainly cannot divide this by 2, or 4, or 6, or any of the numbers that I can divide 12 by. It's possible that I could maybe divide it by 3. I'd have to go through the math. How do you know if a number is divisible by 3?
I forgot.
Its digits add up to a number that is divisible by 3. Well, what does 8 and 5 add up to?
13.
Which is not divisible by 3. That means 85 is not divisible by 3. So, in other words, that's simplified. I can't simplify it any further than that. Let's talk about some of these number properties, because these are going to be important. You know what makes a number divisible by 2, correct?
Yeah.
Has to be even. That's all. Any even number is divisible by 2. All odd numbers are not divisible by 2. Okay? So, I'm going to give you some numbers and you tell me whether they're divisible by 3 or not.
Yes. No.
See how easy it is? Once you know that little trick, it makes it much easier.
I'm actually going to write that down to remember.
Add the numbers up, and they have to be divisible by 3, whatever you get. Now, another one that goes along with that really nice is whether something is divisible by 9. Is that number divisible by 9?
Yes.
Because the digits add up to a number that's divisible by 9, right? They add up to 9. That's all you need. This number is not divisible by 9 because the digits add up to 10. About, is that number divisible by 9?
No.
Is that number divisible by 9?
No.
Add the digits up. What do they come to?
Oh, I thought they added up to 10.
Okay. So they add up to 9, so that is divisible by 9. That number divisible by 9.
Yes.
This number divisible by 9.
Yes.
Because the digits add up to 18.
Add up to 16.
Well, they add up to 18, but then you got to add them again. You don't really have to add them this last time because we got a number that is divisible by 9. 18. So we know this number is divisible by 9, so is that one. So we know numbers that are divisible by 2, 3, and 9. Let's talk about 4. If you know your times tables, tell me if these are divisible by 4.
Yes. No. No.
Good. Now, the rule with 4s are if the last 2 digits are divisible by 4, the number is divisible by 4. That's all you need to know. So this big number right here is all I need to know as to whether it's divisible by 4 is 24 divisible by 4?
Yes.
So I could write a number like something like this. Is that divisible by 4? Yes, because 84 is divisible by 4. What makes a number divisible by 5? I'm going to write 4 numbers here. You tell me which ones are divisible by 5. I'm going to write 3 numbers.
Well, they end with a 0 or 5, so 10 and 35.
That's all you need to know. They end with a 0 or a 5, they are divisible by 5. 6 is, I don't know of any rule for 6 or 7 or 8. I've given you all of the rules I know for divisibility by numbers. But those can be helpful, especially when you're trying to simplify things. In other words, in that one problem where we had, what was it? It was 85 over 12. Okay. This one right here. Well, I know that 85 isn't divisible by 12, first of all. And 12 is only divisible by 6, 2, 3, and 4. So in order to simplify, all I have to decide is 85 divisible by any of those four numbers? Certainly it's divisible by 2, by 3, by 4, and is not divisible by 6. That means I can't simplify this. That 85 twelfths is as low as it's going. I could turn it into a proper fraction. In other words, I could divide 12 into 85, and what do I get? I get 6, I get 7 and 1/12. Okay? That turns it into a proper fraction. But there's almost never a need to do that. This is always my answer I'm submitting on a test. Not this one. Not unless they specifically say, express it as a proper fraction. This is improper fraction. This is proper fraction. But the improper fraction is actually a better answer. It leaves you in a position to handle the next step, whatever it might be coming, better. Okay. We're at the hour mark, so I'm going to stop.